In this video, we are going to continue on with our logarithmic functions, and we're going to look at how we graph them. So I want to start by thinking of this exponential function, and we are familiar with this one because we've already graphed this one, but we'll just do a quick review. 3 to the x. So remember, 3 to the negative 2 power becomes 1 over 3 to the 2 power, which is 1 over 9. 3 to the negative 1 power, that's 1 over 3 to the 1 power, which is 1/3. This becomes 3 to the 0, or 1. 3 to the 1 is 3, and 3 squared is 9. So when we graph this, remember our exponential function looks a little something like this. X equals 1, we're here at 3. And x equals 2, we're up here at 9. And so our exponential function looked something along the lines of this. And I have a hard time drawing this neatly with this tablet, but you get the idea here. Okay? So for our logarithmic function, we can't just figure out log base 3 of x because we have no way of really knowing what log base 3 is. We can't put that on our calculator. So we have to think of this in this equivalent exponential form. So I want you to think of this as y equals log base 3 of x. And then we're going to rewrite this so that we have it as an exponential. We talked about that on the last video, and that would leave us with 3 to the y power equals x. Now, essentially what we've done here is we've changed around. This looks similar to this one, only we've changed around our x's and our y's. So if you were going to make a table of values here, you wouldn't pick your x values as -2, -1, so on and so forth, because in fact, I can't come up with anything. There's nothing that's going to give me -2 here. So instead, pick your y values. Pick the values you want to plug in for y as -2, -1, 0, 1, and 2. And then what we'll do here is when we plug in these values, -2, what we get is 3 to the -2. We know that 3 to the -2 is 1/9, so our x value is now 1/9. Similarly, 3 to the -1, well, we know that's 1/3, so that is our x value, which is now 1/3. And you can continue the pattern on down here. And notice I'm pulling those are similar ones. We just worked them all out here, but now all of a sudden they've switched over to our x's. So now's the trick. We have to graph this. So at 1/9 we're at -2. And at 1/3 we're at -1. And at 1 we're at 0. Okay, so I'm still graphing my x comma y. At 3, x equals 3, y equals 1. And at x equals 9, y equals 2. So now our logarithmic function looks sort of like this. Let's pretend I was going to get closer to those dots to get in there. And it looks something like this. Okay. So the blue one here, that's our logarithmic function, and the black one up here, that was our exponential function. This is going to come down and it's going to follow along the y-axis this time. Okay. So there are some more properties of logarithmic functions, and if you look at page 942, you're going to see those on there. Okay. Now I want to talk about reminding us about domain and range. So logarithmic function is slightly different. Our domain, remember, is our x values and what we can put in for our x values. Notice here, let's look at the red one first. Notice here, my x values never get over here past 0. We never have negative x values. Okay, so for our domain, we say all reals, our x has to be greater than 0. Okay, can't actually be 0 because we can't take the log of 0. If we did that, 2 to the y power would equal 0. Well, we can't ever get 0 from that. And then our range, well, our range goes pretty small right here. Our y values, it gets smaller and smaller as we go this way, and it gets bigger and bigger that way. So we say all real numbers. Okay. Now this blue logarithmic function, I have shifted over 2 units. And so it looks just like the red one, only it's shifted to the right 2 units. So when you say, what is the domain here of the blue one? Well, instead of being all reals x greater than 0, we're going to say all reals x greater than 2. Okay. And then our range, again, it gets very small as we go this direction, and it gets very large as we go this way. So we're going to say all real numbers for our range on the second function. Okay. All right, that's all for this one. We'll see you in the next video.